Okay.
Hello, we're the Civic Squad.
Hello, we're the Sitting Squad. Wait, we're supposed to say it together?
Yes. Hello.
1, 2, 3.
Hello, we're the Sitting Squad. Do we do it?
Yes.
Here
All
is
right.
the sign for the Civic Squad.
That looks like a weird wiggle snake. Okay, so today we are going to talk about long division with a remainder. So I've done a video on long division without a remainder at some point. I'm sure I'll have to link that somewhere, but I haven't linked anything anywhere. But so this is the idea that I'm going to show you long division again, but instead of having 0 as your final kind of block at the bottom, you'll get a number there and how you write that. I'm also going to do a video on synthetic division, and I'll do it with a remainder and without a remainder. Thank you. And then I'll talk about the remainder theorem and the factor theorem. All right, but today is just, right now, it's just long division with a remainder. So I'm going to have to set you down because I cannot math with you in my arms. Are you ready?
Okay. Well, they don't see.
I know, but they'll know you're here. All right, so the nice thing about doing long division with a remainder is you don't have to have a specific problem because most polynomials aren't going to divide evenly. So I'm just going to go ahead and I'm going to divide, I don't know, something like this.
Can I tell you one?
Sure.
Divided by.
We'll just go simple today.
Divided.
X, do you want a plus or a minus?
A plus.
All right. and then
Minus.
What number? Too late.
Mm,
Don't pick a big one. Pick a little one.
from like 1 to 5 or 1
Yeah,
to
1 to 5 would be great.
1 to 5. Can I pick a fraction?
No, you cannot pick a fraction. Thank you for asking me. We'll do fractions some other time.
3.
3. Okay, so we're going to divide 3x to the third plus 2x squared minus 5x plus 7 by x plus 3. Now, if it's not already set up as a fraction, this part, remember, is still your divisor. So it's what I'm dividing by. So it'll go on the outside of my long division symbol. And then everything here will go on the inside. You need to check for a placeholder. What that means is you start with your largest power, and in order to keep order, which sounds weird to say, but in order to keep order, you have to make sure you decrease by 1 power every time. So I went from a cubed to a squared to a first, even though it wasn't written there. And then this one technically is an x to the 0 power, but because that just means 1, we don't need it there. But I didn't skip any steps, so I'm just going to write in 3x to the third plus 2x squared minus 5x plus 7. Okay, now the process is the same as my long division without a remainder. What I'm going to do is I'm going to take just my first term divided by just my first term. So I'm going to take 3, and you can do it in the problem or you can do it out of the problem. So I'm going to take 3x to the third. This has an invisible 1 in the front of it and an invisible 1 as its power. Okay?
Invisible.
Invisible. So,
How come invisible 1?
because it exists, therefore there's 1 of it, and it doesn't have any more power than 1. So they're invisible ones.
But not imaginary ones.
Not imaginary ones. Okay. 3 divided by 1 is 3.
Are there such things as invisible ones?
Imaginary ones, yes. Okay, x cubed divided by x to the first. You look for the difference between them, which in this case is 2. Now I'm going to multiply back out to both parts. So even though I only looked at first term and first term, to get my next part, I have to multiply back to both pieces because this is a binomial. So 3x squared times 3 is a positive 9x squared. 3x squared times 1x is 3x to the third. Now, if this does not match, you know you've made a mistake, all right? It's like the old guy in that movie with Harrison Ford in it. You have chosen poorly, all right? You've chosen poorly by what you have chosen to put here. Your face will not melt, but that's probably too old for the people that watch this video. But what will happen is you won't get this first term zeroed out, and that means that you have a problem. All right, so now 3x to the third minus 3x to the third is 0. You don't have to put the 0 there if you don't want to, but you can always check. Daniel, please be quiet a little bit, please. Now I have 2x squared minus positive 9x squared. That minus, that's negative here, makes this a minus. So 2 minus 9 is negative 7x squared. And then I drop my next term. Okay, now I go back to what I did previously, which is first term and first term. So I'm going to take negative 7x squared divided by 1x to the first. Negative 7 divided by 1 is negative 7. X squared divided by x to the first is x to the first. Now that I have that, it has to multiply back to everything. So negative 7 times 3 is negative 21x. Notice I'm putting a parentheses here. It's because I want you to remember that when you subtract at your step, that you subtract all the way through. You don't have to write the parentheses, but I found that it sometimes will remind people that the parentheses, the minus carries through. All right, so now I have negative 7x times 1x, which gives me negative 7x squared, and there's my minus. Okay, negative 7x squared minus minus turns into a plus, so that's 0. Negative 5 minus minus 21 turns into a plus, so this is now negative 5 plus 21. 21 minus 5 is 16x, and then I drop my 7. Okay, I'm getting a little squished for space, but I think I can make it. Now I'm going to take, once again, first term to first term. So I'm going to take 16x divided by 1x. 16 divided by 1 is 16. X divided by x, that eliminates, it reduces to 1, so you don't need an x. But you have to multiply back out to everything. Okay, 16 times 3. 3 times 6 is 8, carry the 1, that gives me 48, and it'll be a positive. 16 times 1x is 16x, and I subtract. Now, in my previous video, what would have happened here is this would have been a 7 and a minus 7, and it would have gone to 0. But because this has a remainder, what happens is these last two pieces, I already have 16 whole as a number. This is now my leftover. All right, so I'm going to take 48 plus 7. Anybody know 48 plus 7?
55.
55. So we get 55, and that 55 is going to go up here. It's a positive 55, and the way that I show it's a remainder and that it's not a whole is I take and I write what I couldn't divide it by, which is x plus 3, and that's my remainder.
And that's
All right.
woman.
Now, I'm going to, very quickly, I'm going to take this same problem and I'm going to synthetically divide it. All right, I'm going to do a separate video on how you do synthetic division, like more explained. But I just am going to do that quickly because I know a lot of students that know long division also know synthetic division. And if you ever are worried that you didn't do your long division correctly, you might have an easier time with synthetic division checking. So what I'm going to do is I'm going to erase. I'm going to erase over kind of on this half.
Can I help you out?
With erasing?
Yeah.
I'm just going to erase that much. Sorry, you can erase after. Deal? Deal. Okay. So this is not a how-to synthetic division. This is just checking with synthetic division. I'll do a how-to after this. So my divisor for synthetic division will be a negative 3. Then I've got my coefficients, 3, 2, negative 5, and 7. I'm going to drop my 3. Negative 3 times 3 is negative 9. Negative 9 plus 2 is negative 7. Notice, that's what I had right here. Negative 3 times negative 7 is 21. 21 minus 5 is 16. Negative 3 times 16. Uh-oh, did I make a sign error? Negative, negative went to positive. That gave me a positive 16.
Positive 55.
Negative 3 times 16 will give me a negative 48. Did I make a sign error here? I did. Oh no, shame on me. So it's a good thing I checked myself with synthetic division because what happened here is this was really 7 minus 48. So my remainder shouldn't be 55. It should be negative 41 because this is a 7. See, look at that. I said, carry that parentheses and make sure you carry your negative through or your minus through, and then I didn't. 7 minus 48, so it's 48 minus 7, which is 41, and it's negative. Same thing will happen here. 7 minus 48 is negative 41. So that's my remainder. Good thing I checked myself. That's what happens, I guess, when you have 2 children in a video and you're doing math after a long day of doing math. Okay? All right, so hopefully that made sense. The nice thing is the process for long division with a remainder is the same as without a remainder. It's just a little more work because you have to have that remainder show up at the end. All right? Synthetic division is generally going to be faster, but synthetic division, please stop, cannot be used, please stop. Synthetic division cannot be used in all cases, which is why it's good to know long division. All right. Gentlemen,
What do we say?
Bye. Goodbye. We are the Citizen Squad. We will never be the Citizen Squad again. Just kidding.
What?
all right, so this is long division with the remainder, and then checking with synthetic division, which thank goodness I checked myself. And then I'll do a synthetic video at some point too. Maybe I'll kick my children out. We'll see.
Subscribe.
Subscribe and give a thumbs up to these videos, because who doesn't love thumbs? No. Who doesn't love math? All right.
No one does not love math.
That's true.
Goodbye.